continuing on our theme of covariance review, we can calculate the covariance pretty easily, as you can see in the formula. This is from last week as well. And just a quick note about the sum of the cross products that's in the numerator of that formula. That is can be a very large number dependent on the number of cases that you have in your data set. So if you have just 10 cases, let's say you have a very small sample, that numerator will probably not be very large. But if you had, for example, 1,000 cases, that numerator would be huge. So really what we're doing with the covariance is we're taking an average of the cross products. So covariance is literally the average of the cross products in your sample. So that is the whole formula. That's why we don't just take the numerator. We have to divide it by n or n minus 1. Now for the rest of class, it's going to be n minus 1. But just know that minus 1 is a correction, and so that's the reason that we always add it. But conceptually, it's just nice to think about this as an average. I think that really helps. So the way that we standardize the covariance and get the correlation is we divide the whole covariance formula by the standard deviation of x times the standard deviation of y. So remember that from last week. Or we can do the sum of squares of x times the sum of squares of y, and then take the square root of those things, and that gives us the standard deviation as well. So the goal is just to keep thinking through these formulas, write them out, understand them, and imagine one part of the formula is increasing while the rest is staying the same. What's happening to the correlation overall? What's happening to the covariance overall? And I think that will be very helpful for you to think through those things and then really solidify it in your mind moving forward.